Greeting GC candidates, welcome back to School for All. As you people can see, I'm back for this final revision with you. So today I decided to take a crucial section of paper 2, which is data analysis. Why am I saying this is crucial section? This is because data analysis carries how many marks? 20 marks of paper 2. Let's say 20% of paper 2, and 20% of paper 2 means 10% of the overall physics paper. So it means that if you go in the exam, you're having already a 20 on data analysis, there's already 10 on 100 on the overall grade of paper 2. So take it very seriously. So stay to the end of this video if you want to secure your 20 marks in data analysis in paper 2. Okay. Now, as usual, under data analysis, the first thing or the most important thing is linearization. Linearizing a function. So what is the meaning of linearizing? Linearizing or linearization of a function or of a physical equation. It can be a function, it can be a physical equation. Yeah, what does it mean, linearizing? Now, linearizing means putting the function or putting the physical equation in the form y equals to mx plus c. There's the meaning of linearizing. It's coming from the word linear, a straight, something that is straight, a linear, something that is uniform, a straight line. Is okay. So, linearizing a function is putting the function in the form y equals to ms plus c, such that the function should be what? In the form of a straight line. That is the meaning of linearization. Now, my objective today is for all School for All candidates to be able to have the ability to know when the linearization is correct. Yeah, because when you are linearizing, if you don't know if your linearization is correct, that is very dangerous. Yeah, because the linearization is taking, let's say, 3 marks or 2 marks, but from there, all the rest of the equation can be wrong. So my objective here is that you people should be capable to know if your linearization is correct. Now, look at y equals to ms plus c. It means that I should identify that the y term should be made up of only what? A variable. I think you know the meaning of variable. Variable, it means that variable is that physical quantity that is what? Changing, depending to the other quantity. It's not constant. So y should be made up only of a variable or a variable and a known constant. So it can be made up of a variable and a known constant. Why am I talking about known constant? Because sometimes in some question, as you see when you do it, there are known constants which are being given. Known constant means that constant that you're having the value of it. So your y term should be made up of variable or variable plus a known constant. It means that if at the y term here you are having an unknown constant to be determined, your linearization is wrong. Okay. Now m should be made up of what? M should be made up of only constant terms. So it should be made up of only constant terms. When I say constant term, it can be made up of the constant term can have a known constant to be a known constant that we know, and an unknown constant to be determined. No variable here. We should have no variable here. No variable. When I'm talking about variable, there are those physical quantities that are being given in a table. Those are variable because their values are changing depending on certain conditions. Now, and C is the same thing. C should be made up of only constant terms. And that constant term can have what? An unknown variable to be determined. And a known, it can also be made up of a known variable that you're having the value. So after linearizing, you should verify all these conditions. With all these conditions, you are sure that your linearization is correct, and from there, you are already on the right way to have your 20 out of 20. That means 10% of your overall physics paper. Okay, so without wasting time, I think here I will only help you to linearize. I don't have a graph paper here, but at the end I will show you how to come out with what? The scale, because the most difficult part sometimes for students is to come out with the scales of the different axes. Is okay? So here let's say at the end of the video, I will try and do something to show you how to come up with a scale. Let us solve our first question. Okay, so let us take a quick example here. Let us take a quick example. Now, this is a quick example to understand something. Now, let us say I'm having a table. I'm having a table x, y with different values. It's okay. Then I'm asked to linearize. Okay, student. So when you are having an equation, when you are having an equation to linearize, and it's this in the form of a fraction that you cannot separate the two. In fact, you cannot split the fraction into two parts. You cannot separate the variable from the constant. Always do the reciprocal. Like here, I cannot really separate this a constant, this a variable. I cannot separate it. So do the reciprocal. While doing the reciprocal, you see that you can now easily separate the variable from the constant. You see, when you do the reciprocal, you come out with an equation of the form a plus b all over c. And we all know that what? A plus b all over c, same denominator, can split into two, a all over c plus b all over c. So doing the same here, I will have alpha x all over beta plus beta square all over beta. You will see that I will have 1 all over y simply equals to what? Alpha beta x plus beta. So this is in the form of y m x c. That's all. It means that the graph of 1 all over y against x is a straight line where the gradient is alpha over beta and the y-intercept is beta. As easy as that. So remember it. Remember, it's okay, do the reciprocal. And you are seeing that my y term is only made up of what? A variable. My x term is only made up of a variable. And my constant, the gradient, is made up of only constant terms to be determined. And see, only constant, no variable are there. Okay, so that is it. That is it. That was a small example. Now let us take sample DCE questions. Okay, our first sample DCE question here is okay. We are having the variation of an electrical resistance with temperature of a given material wire is given by the equation RT equals to R0 in bracket 1 plus alpha big T plus beta big T square. It's okay. Where R0, alpha and beta are constant of the wire. Consider R0 to be 20 ohms. The table shows values of RT and their corresponding values of T obtained from an experiment. So we are having a table of RT against T. It means that you should have already an idea on who should be on the y-axis and who should be on the x-axis. It's okay. Now, okay, let us try and linearize it. Okay, so what you can do here is you can put a pause on the video, then you try to solve it. Then you come and look for the correct correction. So let us come and do the correction now. Let us come and do the correction. Okay, I'm having RT equals to R0 into 1 plus alpha T plus beta T square. I want to linearize it. I know that R0 is a known constant. It means that I know the value of R0. So it means I can manipulate it without even fear. No fear when I'm manipulating it. It's okay. I'm seeing that this R0 is disturbing me. I don't want to open it. I can bring it here because there's no problem. R0 can be part of my y term because it's a known constant. So I will bring it here. I will divide both sides by R0 like this. You see that I will have RT all over R0 equals to 1 plus alpha T plus beta T square. Are you seeing that? It's just from simplifying the equation. This R0 here, no problem. It is a known constant. If it was an unknown constant to be determined, I cannot put it here. It's okay. Yeah, since it's a known constant, I can put my R0 there without any problem. Now, I have another difficulty here. I'm having alpha, which is a constant to be determined, and beta, which is a constant to be determined, because the equation is to plot a suitable graph, plot a graph where alpha and beta can be determined. So I'm having alpha t, beta t square. Two known constants to be determined related with variables. That is not correct. Okay, so the next thing I can do here, I can bring this one on the right hand side. I'll have RT all over R0 minus 1 simply equals to alpha t plus beta t square. Now for me to eliminate this t square, there is no way I should divide all 2 by t. By dividing all 2 by t, I'll have what? I'll have r t. Let me do the LCM. RT minus R0 all over TR0 equals to what? T cancel here. I'll have alpha plus beta t square. No, t here cancel 1 time, so beta t. As easy as that. As easy as that. You see that? You have it. So therefore, I will have RT minus R0 all over TR0 equals to beta t plus alpha. So all this should be y, this should be what? M, this should be x, and this should be c. As I said before, now people should look up. It's not obliged that we are having the same thing, but you should be able to know if your linearization is correct. This is my own. Verify with your own. This is my own. I can verify if it is correct. So you should be able also to verify on your site if it is correct. Now, look up here. It is very easy here. Look up. C is a constant. C is a constant. Alpha is a constant. Correct. M is a constant. That can be made up of what? A known constant and unknown constant. My beta is a constant. Unknown, that should be determined. Correct. Y. All the terms of y are only made up of variable and known constant. Let us verify. RT, variable. R0, a known constant. T, variable. R0, a known constant. Correct. I'm sure by 100% that my linearization is correct, and it will permit me to go and calculate my unknown constant easily. Okay. Now, that is the linearization people should check. As I said, we are not forced to have the same thing, so you can still verify. As I said, verify all your terms if they have the correct, let's say what, condition. As I said in the beginning of the question, the y should be made up of only variable and non-constant. M should be the gradient, should be made up of only what? Non-constant or non-constant with unknown constant. Is okay? And C should be made up of unknown constant, sometimes unknown constant plus non-constant. It depends on you. But no variable should be found here. M and X, no variable. Okay, next question. Okay, the next question we are having. When an electromagnetic radiation of sufficiently high frequency falls on a clean metal surface, electrons are emitted from it. Even the most energetic electrons prevented from leaving the metal surface when stopping potential V is applied to the metal. The frequency of the incident radiation and the stopping potential of the material of the metal are related by the equation HF minus HF0 minus EV equals to Z0, where E is the electronic charge, H and F0 are constants. In one such experiment to verify the relationship between the frequency of the incident radiation and the stopping potential of an clean zinc plate, the following data was obtained. So I'm having V against F. The following data was obtained. Okay. Now we should look up. We want to plot a suitable graph from which H and F0 can be calculated. So that is it. You're having the question, students. You can put a pause on the video and you try to do it. Then let us do the correction. I will first of all come and indicate my unknown variable to be determined. My unknown variable here to be determined is H and F0. And I'm having known variable here. Known variables here are there's only known, well, I think there's only one, which is E. There is a known variable. From here already, I should already have an idea on how this thing will look like. And my variables are My variables are V and F. Those are my variables. So with these informations, I should have an idea already. Let us go fast. It means that what? I can bring this one on the other side. I will have EV equals to minus HFZ 0. I think that is already linearized, right? And now divide all 2 by E. I will have V equals to HEF minus HF0E Y M X C. So that is it. So if you're having the same thing, that is good. It means that you're understanding already. That is it. You can verify. You can verify. C is made up of only constants. That is 1 which is an 2 which are unknown constant to be determined, and 1E which is a known constant. We're having it inside the formula bullet, the electronic charge. My gradient is only made up of constants. 1 which is a constant to be determined, another one a given constant. My variables are only made up of variables. My y term is only made up of a variable. Therefore, I'm sure that it is correct. Voilà. And sometimes they will ask you the significant. The significant maybe of F0. Now, most of the time, the significant, you should first of all know the theory behind the physical equation. Like here, we are talking about photoelectric effect. It means that if F0 has the unit of maybe second, you should already know that what F0 should be a frequency. Now, which kind of frequency? That one now is from your theory in physics. Inside your book that you read it in class. F0 is having unit second, means that it's frequency. Now, which type of frequency? The threshold frequency. The threshold frequency. So most of the time, you can take or you can have your significant from the unit of the constant. Is okay. So when you have the unit of the constant now, you know which kind of physical quantity is it. Like here is frequency. Now, which type of frequency now? You should know the theory behind the equation. We are talking about photoelectric effect. So F0 here should be what? Should be the threshold frequency. Okay. Then let us go to the next question. The next question now. Okay, we are having the internal resistance R can be measured by using the relationship between these quantities. R equals to big R in bracket L prime minus L all over L. Okay. Where R is the value of resistance box, L is the balance point corresponding to R, and L prime is corresponding to R, and L prime is the balance point when R is at infinity. The following table were obtained for such an experiment. So we are having the following table. It was obtained for such an experiment. Now, I should first of all identify my two variables are what? Here my two variables are R and L. Those are my two variables. It means I should have a graph of R against L. Okay. Or, yeah. Now, those are my two variables. Now, let us see. Are we having known constants? Are we having known constant? We're having L is the balance point corresponding to R. And L prime is the balance point when R is at infinity. It means that L prime here is a known constant. In fact, we are having the value of L prime. And from the table, look at the table. L prime is the value of R. Is okay. L prime is the balance point corresponding to R. And L prime is the balance point when R is infinity. You can see that from the table, when R takes infinity, I'm having 95. It means that 95 represents L prime. That is the value already. 95 centimeters. That is L prime. It means that L prime is a non-constant. Okay. L prime is a non-constant. L is a variable. R is a variable. Now, small r. Small r is the internal resistance. Can be measured by using A. Okay. Okay, means that R here, R, because you are asked to plot a suitable graph from which the values of R can be determined. R is the unknown constant to be determined. R is that constant to be determined. Okay, with those information now, I can now linearize. Okay, students, so why knowing this already, that L prime is a known constant and R is an unknown constant to be determined, Now we can now proceed with the linearization. So people should try it and you come back and take the correction. Now let us see if what you did is correct. Okay, now look up. What I can do here, as I always said, avoid opening the bracket when you are not sure. Like I'm having a fraction here, I'm having area. I can first of all divide both sides by area like this. Are we together? To remove this area, I will have r all over small r all over big R equals to what? L prime minus L all over L. Then I split this into two. Fraction. I'll have L all over L prime all over L minus L divided by L is what? Is 1. It's okay. Now can I say that this is my y? No. Because y should not be made up of what? R which is what? A constant to be determined. So what I can do is that I make L prime all over L the subject. I will have L prime all over L equals to R into 1 all over big R plus 1. I bring this one here. Now I'm sure that is correct because L prime is a known constant. We are having the value 95. L is a variable, it means that my y already is correct. Y should be made up of what? A variable and a known constant. R here, constant to be determined, means that my gradient. Here is only made up of what? Variable, it means that here should be what? X, and this one should be C. So if you're having the same thing, that is very good. It means that you're understanding already. Now, what you people should know also is that you people can still verify your linearization with the unit of C, because the unit of C should coincide with what? The unit of who? Y. Because C here, the y-intercept is ty. It means y-intercept happens when x is 0. It means that they should have the same unit. Y should have the same unit as C because it's the same physical quantity. Is okay. Look at L prime divided by L. The unit of L prime is centimeters. The unit of L here is also centimeters. Centimeter by centimeter 1, making it to be unitless as this one. You see that I'm 100% sure that my linearization is correct because the unit or the dimension of my y-intercept coincides with my y. I hope you understand it. So that is it. If you're having it, that is good. That is good. It means that you are following it up. Next question. Okay, next question we are having. The resistance R of a thermistor is related to the absolute temperature T by the equation R equals to R0 exponential of 1 all over T minus 1 all over TZ 0. Okay. We are having something like this. And they name it equation 1, where R0 equals to that. So R0 is a known constant, we know it, is the resistance at the temperature T0 and beta constant under certain condition. We are asked to plot a suitable graph to determine the values of beta and T0. So my T0 here, T0, there is beta here. Okay, I'm seeing there is beta here like this. Okay, so we can also see that what? Beta and T0 are unknown constant to be determined, so they are constant to be determined, This one is a known constant, so we have the value of this. It's a known constant. These are my variables. Variables are V and T. Okay, as I said, whenever you are having a known constant here, which is disturbing you, bring it on the right hand side, no problem, because it's a known constant, you're having the value. So I will divide both sides by R0. If you can't say here, I will have R all over R0 equals to exponential of beta 1 all over T minus 1 all over TZ 0. As easy as that. Now I'll apply link, because the only way to remove the exponential, I should apply the link. So I'll apply link. I'll have link of this is simply equals to what? Beta 1 over T minus beta T over 0. I think that is from here already, that we can already say that it's linearized, right? Because here, this is my Y, here should be my X, here should be my M, and here should be what? C. Beta, T0, they are all constant, correct? Beta, constant, variable with a known constant. My linearization is correct. So if you are having this, that is good. If you are not having, please try and see how I came out with it. Okay, so it means that when I will draw a graph of y against link r all over r0 against 1 over t will give us a straight line where our gradient is beta and our y-intercept is negative beta all over t0. Now, yeah, so now I'm saying here, determine the unit of beta all over t0. Simple as that. The unit of beta all over t0 should be the unit of who? Should be the unit of the y term. And I told you that when I'm having ln function, sine function, cosine function, exponential function, all of them are what? Unitless. It means that their unit is what? 1. It means that if my y-intercept is having the same unit as the y term, and the y term is having ln of this, means that this is what? Is 1. Therefore, from here I can say that what? The unit of beta all over t0 is simply equals to 1. Are you seeing? It's simply equals to 1. So no 2 marks there is for this, for even nothing. So let us proceed to the next question. Okay, the next question we are having is student investigate the Doppler effect by measuring the observed frequency f of a car horn as the car approaches a stationary observer with speed u. The table below shows the measured values of the observed frequency f for different values of the speed. Okay, we are having a table. It means that our variables are u and f. Okay. Now, theory suggests that for a source moving toward a stationary observer, the observed frequency f and the speed of approach u are related by the expression f equals to lambda all over lambda minus mu k, where k and lambda are constant. Plot a suitable graph that can be used to determine the values of k and lambda. 11 marks. Use your graph to determine the values of k and lambda. State the physical significance of k and lambda. Okay. So student, you can pause your video and you go and solve it. You come and take the correction. Now, from this, I already know that f and mu, let's say u, it's even u, it's not mu. F and u are my variables. K and lambda are what? Constant to be determined. So the first thing to do here, I will have f here is the same as lambda k all over lambda minus u. Now you can see that I'm not dividing both sides by k and bringing this k here. No, because k is an unknown constant. I don't know the value of k. Because if I do that, I cannot create a new table where I can do f all over k because I don't know the value of k. So I will leave that k there. I can never bring it on the right hand side because it is what? An unknown variable to be determined. It should not be part of my y term. Okay. Now from here now, can I split this into 2? No. It means I should do reciprocal. Anytime you're having a fraction that you cannot split into 2 fractions, you should put it in the form. You should do reciprocal so that it should be in this form. So I will have here lambda minus u lambda k. So while doing this, you see that you have 1 over f equals to what? Lambda all over lambda k minus u all over lambda k. Lambda cancel here. I will have 1 over f equals to 1 all over k minus mu all over lambda k. By rearranging, I will come out with the linearization. I will have negative u all over k, 1 all over lambda, then plus 1 all over k, making this to be y, this to be m, this to be x, and this to be c. As simple as that. Let us verify. 1 over f, variable, correct. Mu all over k, make up of only constant, correct. 1 over lambda, variable, correct. 1 over k, constant, correct. Now, the next question, let us go to see the state the physical significance of k and lambda. That is, I think it's quite easy. Look at the unit when you calculate. It's okay when you come up with the gradient and all those things. Take care of the unit. From here, I can already see that the unit of k here is per second because it's the unit of who? Frequency. Are we together? So the unit of k here should be what? Per second. Because, or hertz. Because it's the unit of what? Frequency. Look at 1 over f. 1 over f here is what? Second. 1 over s period second. So it means that 1 over k here should be also second. Therefore, making the unit of k to be per second. And if I'm already having the unit of k to be per second, it means that what? K should be what? Frequency. That is already an idea. Now, the significance of that k of that k, now you go inside your formula book, I think it should be the frequency of who now is that Doppler frequency, that apparent frequency of the car, because when the car is moving, the frequency changes. It's okay, when the car is approaching, you see that the frequency changes. So that K there should represent the apparent frequency or the Doppler frequency. Is okay. Now from there, now there's the significance of K already. Then from lambda, surely lambda is the wavelength. Surely when you come out with lambda, lambda will give you the unit of distance. Therefore you can conclude that what the significance of lambda is what is the wavelength of the sound produced by the car. Now the next question we are having, in an experiment to determine the capacitance of a cylindrical capacitor, the following data was obtained when the fully charged capacitor was discharged to a 50.0 kilo ohms resistor. So I'm having Q here and here I'm having T. Those are my variables. I'm having the equation Q equals to Q max 1 minus sigma exponential of negative T all over beta. Okay, so that is my equation. We are asked to, the discharge process is described by the exponential equation, that is it, where K is the charge on the plate of the capacitor at time T, Q max is the maximum charge, and sigma and beta are physical constants. Now what you should know here is that Q max, is it a known or unknown constant? It is a known constant because it is gotten when the time is at infinity. So when you go on your table where time is infinity, there is your Q max. And that Q max is how many? 500 microfarad, because here is in microfarad. As simple as that. It means that since this is a known constant, I will divide directly both sides by Q max directly, because it is a known constant. Means that it will not disturb my y term. Then I will stay with something like that, exponential of negative T all over beta. Now I cannot apply link here directly because you are seeing an exponential here. You should apply link to linearize the exponential. No, why I cannot do that? Because when I'm having maybe A minus B, some students are doing this error. They think that A minus B is link A minus link B. No, never. It's okay. Link A minus link B is rather link A all over B. So to avoid doing this mistake by applying link here, make sure that when you want to apply link, on the other side you should have only what? A term, not separated by what? A sign. You should have only a term. It's okay. Avoid precipitate yourself and putting the link, and then you come and do this rubbish or that mistake. So what am I supposed to do here? I should make sure I should have a term here. I should not have two terms before applying the link. So this one should come here. I'll have Q max here minus 1 equals to negative sigma exponential of negative T beta. Now to avoid what we call some errors, yeah, this negative, we are not having link of a negative number, so it's better I should remove this negative here before applying the link. So I should remove the negative. Why remove the negative? I have 1 minus Q all over Q max equals to sigma exponential of negative T all over beta. Then I can now what? I can now easily apply the link on both sides without fearing. So nothing to fear there now. I'll have a link sigma exponential of negative T all over beta. So while doing that, I will come out with the answer link 1 minus Q all over Q max equals to what? Equals to, I'm having negative, okay, negative 1 all over beta T, then plus sigma. When I will do link AB is the same as link A plus link B. I'm applying it here. So I'll have link exponential. The exponential will go plus link sigma. So that is it. As simple as that. So this one is my Y. This one is my C, X, and M. From there you can verify. So you can verify if you're having this there is correct. It means that's good. It means that you're following up. This one, verify. It's only made up of what? What is inside here is only made up of what? Constant. It's okay. A variable and a non-constant. Here, constant, variable, constant. My linearization is correct. Okay. Then they proceed by saying determine the value of sigma and beta. From your gradient, you have the value of sigma and all those things. What is the physical significance of beta? As easy as that. You see that beta here. I'm sure that you see that beta, the unit of beta there should be what? Second. The unit of beta should be second, therefore making it to be what? Time. Is okay now. Now, which type of time? You should now know the theory behind what? Behind the physical quantity, the physical equation you are having here. The theory here we are talking about what? A charging process. Is it charging or discharging? No, we are discharging, pardon. We are talking about a discharging process. A discharging process means that beta here should be the time constant. Beta should be the time constant. And that will even help you to do the B part, determine the capacitance of a capacitor. We all know that what? From time constant, we are having 2 equals to RC there. For the capacitance is what? It's a time constant all over R. And that time constant is who? Beta all over R. As simple as that. You have your mark and you are happy. Next question. Now we are having external resistors of resistance R are connected to a power source in series with a current measuring meter which reads current I. The current through the different resistors are shown in the table below. Okay, then the current and the resistance are related by the expression. We are having the expression relating current and resistance equals to B. Okay, where A and B are physical constants of the circuit. Roman 1, plot a suitable graph from which values of A and B can be obtained. Roman 2, hence use the graph to obtain the values of A and B. And Roman 3, what are the physical significance of A and B? Okay, now students, let us see what we can do here. We all know that what A and B are constant to be determined, though they are not known constant here. Okay, I can proceed by someone can see open the bracket. It's okay, so you people should put a pause on the video and try to do it. Then you come and take the correction. Someone can see, let's say, open the bracket and see how to manage to play with those terms. Or you can still divide both sides like this. Someone can still divide both sides by R plus A like this. And see what will happen. When I will divide, I'll have I now equals to B all over R plus B. At this level now, I know that I cannot separate this fraction into 2. So what am I supposed to do? I do the reciprocal on both sides. I will have R plus B all over B. From here now, I can separate into 2. I will now have R all over B plus B all over B. Now, B all over B. Pardon. It is A. Here it is A. Making here to be A. Making here to be A. Okay. Now, I will have 1 all over I equals to R all over B plus A all over B. From here, I can see that what? I can rearrange it in such a way that here should be my Y, correct? Because it's only made up of variable. 1 all over B, R. Here should be M. Here should be X. Therefore, A all over B should be who? C. I hope you are seeing it. Very correct. Only make up of variable, correct? Only make up of a constant, correct? Variable, correct? Make up of constant, correct? Now, when I'm having this equation, if you're having the same thing, that is very good. It means that you are following up. That is it. If you're having this now, it's not false that you're having the same thing here, because another person here can still come here and open. I think if you open here, you have something like this. B. Then you have IR equals to negative A. I then plus B. This one is Y. This one is M. This one is X. And this one is C. It's still correct. It's still correct because IR are made up of what? Variables, correct? A, constant, correct? Variables, constant. It's still correct. It's okay. It's still correct. And you see that it's even, I think it's even the same thing because look at B here. Look at B here is what? The unit of B here should be the unit of IR. IR is voltage. B is voltage. Look at my B here. My B here, you see that when I will do the gradient here, gradient is changed. It will be changed in 1 over I divided by change in R. It will be what? It will give us 1 over IR, which is 1 over voltage. Are you seeing that B here? The unit of 1 over B is the same as the unit of 1 over I. B here, the unit was what? Voltage, IR. It means that what? It's the same as RR equals to 1 over B. Therefore, the unit of B is also what? Voltage. It's the same thing. So be careful. It's the same thing. Are you seeing? You see that when you use here, you have B here, which is your y-intercept, will give you the unit of voltage. You have gradient here, which is 1 over B. When you find B, you also give the unit of voltage. They are the same thing. So if you are having any of these linearizations, you are correct. That is good. Let's go to the last linearization I want us to do. We are having, in a displacement method of determining the focal length f of a convex lens, the convex lens is placed on an optical bench between an object and a screen and the position of the screen is adjusted until a sharp image is formed on it. The distance d between the object and the screen is recorded. The displacement d of the lens along the optical for which another sharply focused image is produced on the screen is noted. The relationship between the variables is given by the f equals to d square minus d square all over 4 big D. The table below shows the values of L and D for one such experiment. So I'm having D here, I'm having what? Small d. So big D and small d are my variables. It means that my only constant here to be determined is f. There's nothing difficult here. So I leave you time to go and do it, and you come and look for the correction. Now, there's nothing difficult here, as I said. Look at, if I cross multiply, that is all. If I cross multiply, I'm having what? Let us cross multiply and see. If I cross multiply, I'll have d square minus d square equals to what? Equals to 4f big D. That is all. This is y, make up of what? 2 variables. It means that y is correct. This what is what? X, m, my gradient, and this one is x. M, gradient, only make up of what? Constant, correct? And d, my variable. That's all. So if you have this, that is correct. So that is all about what I wanted to do, what I wanted to work with you today. Okay, now let us proceed with the scale of some graphs or some tables. So as an example, I will take for example on how to come up with a example on how to come out with the scale. I think I will take June 2025. So I try to represent a sample of a graph paper to make sure that we are having 22 squares here and 18 squares here. Now let us see. You are having. I will see how to come up with the scale quickly. We are drawing a graph of length P against H, as you are seeing, where here H is times 10 to the 2. Okay. So here we are having this times 10 to the 2 meters. Okay. Now we can see that what the values of H are, let's say, reducing. It means that it's the biggest value is the first one and the smallest is this one. Now I want to come up with the scale of length P. Another one, if I take the difference between the biggest value 4.4 minus the smallest value 3.36, you see that you have 4 minus 4.4, pardon, minus 3.36. You're having something like 1. It means that the separation, let's say the width, is okay between 4.4, the biggest one, and the smaller one is 1. It means that here is most appropriate to take 0.1 unit to represent 1 square. Are we understanding? It means that it's most appropriate for us to take 0.1 unit to represent 1 square, so that we should have at least 9 squares that is being used. Is okay? Okay. Now from there, now I will try now to see. I'm having 22 squares. And as I said, please try and choose even, let's say even intervals, like 2 squares. You should take 2 squares, 4 squares, 6 squares, 8 squares, and order to take even interval, because with odd interval it will be very difficult for you. Now here, and it is not a must that you start at 0. Like here, I'm having 3.36. I can approximate the starting point here, maybe to be. I will see. I will approximate. You will see together. Now the first time I can consider, since I'm taking 0.1 to represent, let's say, I'm going 0.1 unit. Now let us take maybe 2 squares to represent 0.1 unit. Like if I start here, I would say from here to here and here to here represent 0.1 unit. That is the meaning of taking 2 squares to represent 0.1 unit. If I do that, I will see that what? How many? Let us take 0.1 to represent 2 squares. Now, how many squares are there? 22 squares. So I will take 22 divided by 2 squares is how many? I'm having 11 squares. I will now take 11 squared times 0.1. I will see the biggest. I will see 0.1 times 11 is giving me 1.1. It means I can go up to 1.1. It means that if I start maybe at 3 plus 1.1. If I start at 3, I will take 3.1.1. So I will take 3 plus 1.1 is giving me what? 4.1. It means that my biggest value will be 4.1 here. But 4.1 is still what? It's still smaller than 4.4. All my values are not fitted inside my graph, dangerous. My objective is to make that all the values should be fitted at least 3/4 of the graph, but not that some of my value cannot enter. No, it means that I can take my starting point maybe at 3.1 plus 1.1 will give me 4.2. It's still small, so therefore I can take my starting point at 3.3. It means that I approximate here, and I say that what my first value is 3.3. I'm sure that when I take 1.1 is when I sum all the 0.1 for 11 square, I'll go up to 1.1. When I'll take now that 1.1 plus my starting point, which is 3.1, I'll have 4.4. Very correct. Perfect. Because my last point will be here, my first point is taking all the graph is even perfect than 3 all over 4. That is it. So if I take my starting point, I approximate there my starting point at 3.3. It means I will count 1, 2 squares. I will go to how many? 3.4. I count again. 1, 2 square, I go to 3.5. 1, 2 square, I go to 3.6. 3.8. 1, 2, 3, 4.4. Perfect. As easy as that. Because some will go and divide there, use no. As easy as that you have. I told you that you can approximate your starting point. That is the key point there. When you can approximate your starting point, that is all. Now for this part, for my x-axis, what we call the abscissor, because this is the ordinate, the abscissor axis, we can also see that what the biggest value here is 90, the smallest is 15. What is separating them? Let me see the interval separating them. 90 minus 15. We are having an interval of 75. 75 units are separating them. No problem. If 75 units are separating them, I'm having 18 here. If I take 1 square to represent 1 unit, it means that when 75 units are separating them like that, you cannot even take the interval to be 1, 1. No. You should start at least from 10 like that. 10, then you maybe go to 15. In fact, let us start at 10 or 5. If I start at 5 units to represent 1 square, because the separation is too big. Look at 75. 5 units to represent 1 square means that what? The first square here will be 5. It means I should multiply 5 times 18. I'm having 90. It means that if I take 1 square, if I start at 0, then I'll have 5. I will reach to 90. Is it making sense? Yes. Because my biggest value is 90. My first value is 15. So it means that I'll have 5, 10. 5, 10, 15. And I'll have 90 here. Very correct. I'm starting here. In my starting point, I'm occupying from here to here. Are you seeing? From here to here of my abscissor. That is already 3/4. It's even more than 3/4 of my axis. Very correct. It means that my graph we will start somewhere here. So my graph will be somewhere like that. Therefore, 3/4 of my graph. Very correct. Because this is my starting point. This is my ending point. That is it. You see that when the interval is big, the interval between the first and the last is big. It means that you should also increase the unit that 1 square should represent. Like here, I started to take 5 and see. When I took 5, then I multiplied by the number of squares, 18. It gave me 90 exactly. It means I can go and find. And now you verify, please. When it gives you 90, the last number can fit already. Now go and verify if the first number fits accurately. Because if the first number is fitting somewhere here, let's say maybe if the first number here maybe was let's say 50, if it fits somewhere here, you see that this is not 3/4 of my axis. So make sure the first number should fit somewhere near the origin. If it's not fitting somewhere near the origin, then you approximate the axis. You can start even with that first number to approximate the axis such that your graph or all your points should occupy 3/4 of your abscissa of your axis. So that is all. As easy as that. It's okay. And we have a good scale no matter how you are, I don't know. I don't want to say dull. No matter how you are lazy, you cannot fail the curve. After a good linearization, with a good scale, you cannot fail the curve and the gradient. So that is it. So data analysis, I think, is 20 minutes or 30 minutes. Yeah, a good student that is prepared enough, if you had 1 week for that, should do even 15 minutes there. Yeah, you can do 15 minutes there and you take the rest of the time to verify your work. So that is all about data analysis that I wanted you to work on it. Okay. So please remember, as I always say, school don't finish after the GC. Please, all those students that are near Nguso or a source, mobile source, you should join us on the 15th. On the 29th of June or the 30th of June for a great career orientation for all those that want to do concours, for all those that don't even know what to do. So you people should join us. Our centers are at ASOS, Mongo Betty, at Descent 11 Gusso, at Polish Polyvalent. So these are the days. Those that are not writing for them at the 29th of June, people should join us there for a great career orientation and the welcome test for those writing concours. And the 30th of June for those that will finish further math and join us for the career orientation and the welcome test for those writing Polytechnic. So it's Mr. Tube, your physics teacher for School for All. So we are together.